For example 12.4, I made another video while I was discussing the chapter, and I discussed example 12.4 using the Clausius Clapeyron equation to find some information about dichloromethane. But in this example, 12.5, we're going to be using the 2-point form of the Clausius Clapeyron equation in order to predict the vapor pressure at a given temperature. So remember, the 2-point form of the Clausius Clapeyron equation says that the ln of P2 over P1 is equal to negative delta H of vaporization over R times the quantity 1 over T2 minus 1 over T1. So if we know the boiling point for a substance and the delta H of vaporization of that substance, we can calculate the vapor pressure at any temperature. So methanol has a normal boiling point of 64.6 degrees C and a heat of vaporization of 35.2 kilojoules per mole. What is the vapor pressure of methanol at 12 degrees C? So we're given all this information. If the normal boiling point is 64.6 degrees C, then we know that boiling point occurs when the pressure is 760 torr. That's equal to atmospheric pressure. We know the delta H of vaporization, and because that's the boiling point, we know T1, and we know T2, so we're going to find P2. So we just plug everything in, okay? But first we have to calculate our temperature in Kelvin. So we convert our temperature to Kelvin. 64.6 plus 273.15 is 337.8 Kelvin. Our T2 is the T2 in degrees C plus 273.15, which gives us 285.2 Kelvin. So we're going to substitute into our equation the ln of P2 over P1. Just to keep things simple, we're going to go ahead and put in the delta H of vaporization. We're going to put in T2, and we're going to put in T1, okay, and we're going to put in R. So everything on the right side, we're going to subtract, okay, first, and then we're going to divide top by bottom, and we get negative 2.31 on the right. Okay, so now we have this. ln of P2 over P1 is equal to negative 2.31. Now, how do we get rid of a natural log? Okay, how do we get rid of the natural log? We take e to the that thing, and that gets rid of the natural log. So we can take e to the ln of P2 over P1 equals e to the negative 2.31. So here we get P2 over P1 equals e to the negative 2.31. And so we're really looking for P2 because we know P1, and that's 760 torr. So P2 equals 760 times 0.0993, and that gives us 75.4 torr.